Okay, so for question 16 you're going to have to remember the rules for when we're manipulating functions. So the ones you're going to need in this case are the fact that minus f of x is a reflection, let me get this in focus, reflection in the y-axis. Sorry, what am I talking about? Reflection in the x-axis. And you're going to have to remember that f of x plus 3 is a movement of 3 to the left. So remember, x plus 3, people see that, maybe instinctively they think 3 to the right, but it's actually 3 to the left. So if we think about the original point A, which is at 9, 1, so we've got the point A. If we then do the f of x plus 3 bit, which would move it 3 to the left, that would take you to the point 1, 6, which is this point here, which I'll do just to show the difference in red. And then if we do the bit where you have the minus in front of it, minus f of x, it reflects it in the x-axis, so it's going to bring it down here instead. So the x-coordinate will still be 6, but when you reflect that over the x-axis, your new y-coordinate will now be minus 1. So from where we started, this is just a very vague sketch to explain what we're doing. We're moving it 3 to the left, and then because of this we are reflecting it in the x-axis, so our final coordinates come out as 6 minus 1. Okay, let's do 17 at the same time. So you are given two formulas up here, so let's just write both of them out. V is equal to a third pi r squared h. Now we know what r squared is. If the diameter is 24x, the radius will be half of that. So let's just write in, we know that the radius is 12x, so it's a third pi 12x squared, so it's the radius all squared, times by h. Well, we know that the height is 16x, so we'll put that in there. And the other one is the curved surface area of the cone, so let's just say the surface area is equal to pi times by the radius. Again, we know it, so we'll put it in, times by L. Now L is the slanted side up here. We're not given that, so we're going to have to leave that as L. The surface area, though, we are told in the question the surface area is 2160 pi, so if I replace that, and then actually I can divide both sides by pi, so I'm left with something that looks like this. So 2160 is equal to 12x times by L. I've simplified the surface area a bit. Now, the volume, we are still a way off in terms of being able to work out what the volume is. We need to find out what x is first. Down here, maybe if we work out what L is, we might have a chance of working out x, which will then allow us to answer the question, which is to find the volume, to find V. If we can work out what x is, it's the only thing that's stopping us working out the volume. So if I try and work out what L is, well, up here, if I draw this in, this is a right angle triangle. So let's just do a version of it down here, where the height of your cone is 16x, the radius is 12x. So using Pythagoras, this side here will be equal to 16x squared, 16x all squared, it's this side squared, added to this side squared, so I know it's algebraic, and then we would have to square root it, because we'd say that the square of this side is equal to this side squared, added to this side squared. So to work out what this side actually is, I'd have to square root this. Now if I work this through, 16x all squared, or 16 squared is